Let's expand logarithmic functions using the power rule for logarithms. So how this power rule works is if you have whatever's on the inside of the logarithm, the exponent is attached to everything on the inside here. What you're allowed to do to expand this is we can move this exponent down in front out of the exponent and make it a multiple out in front of the logarithm. So let's work through a few examples. We'll talk through some exponent rules as we go through besides just this one. So as we're asked to expand this, you notice that the exponent is attached to everything on the inside here. So what I'm going to do is bring that 5 down in front and make it a multiple. So 5 multiplied by log base 2 of x. Next up, natural log of x cubed. Sure, it's a natural log, but that's a logarithm, log base e, so it gets the exact same properties of logarithms. So again, the 2 is attached to everything on the inside. We can move it down in front and say 2 multiplied by natural log of x. There we are, fully expanded. What about when we're given something like this, though? We have log base 3 of 25. Well, how I probably want to do this is I would rewrite the 25. Maybe you want to factor it, but I think we know that 5 times 5 is the same thing as 25, but that's the same thing as 5 squared. So really we could replace this as log base 3 of 5 squared. Then we can use this power rule because that 2 is attached to everything on the inside, move it down in front, 2 multiplied by log base 3 of 5, and it's fully expanded. But what happens when we get to some different rules like this? Well, we do have a fraction inside, so you may be thinking the quotient rule. That's okay if you do. I'm going to go through this 2 different ways. I'm going to go ahead and say natural log of 1 minus the natural log of x squared. That would be the quotient rule. Numerator gets its own natural log. Denominator is subtracted away, gets its own natural log. Then we have this 2 is attached to everything on the inside. We're allowed to move the 2 down in front according to the power rule. So that brings down minus 2 natural log of x. You may notice that I've left off the natural log of 1. Why that is because whenever you plug a 1 into a logarithm, that always gives you a 0 for a result. Think about those key points on our graphs. The key points on our graphs for any of these logarithms, one of those key points was always going to be 1, 0. All right, same idea here. You plug in a 1, you're going to get a 0 out. So this would be the fully expanded version that we would expect as a solution. All right, let's also go ahead and mention an alternative way to do this is simply rewrite our natural log. With what's on the inside, you could rewrite this with a negative exponent by moving this from the denominator up to the numerator. You could say that's the same thing as x to the negative 2nd power, in which case it's a little bit easier to see. If you move that down in front, we get this exact same negative 2 natural log of x. Okay, natural log of 1 over 4 to the k power. Again, this is one where we want to get more and more comfortable with our power rules, with these different exponent rules, where what we can do is we can rewrite this and move the k up to the numerator, the 4 and the k, by making it a negative exponent, in which case our exponent is attached to everything on the inside, so we can move it down in front and make it a multiple. Fully expanded. There we go. Very, very similarly, don't get thrown off that we have 2 letters going on here. That same rule applies that x can come down in front, become a multiple. Sorry, this is a log base 2. And then the y will remain inside. All right, last 2 have to do with some new, well, you've seen these square root rules before, but let's just review them over real quickly. You'll notice that we have a square root over x on the inside here. It's going to be very beneficial if we get comfortable with rewriting this. So we have the common log of x raised to the 1 over 2 power, because the index here is a 2 and we're raised to the 1st power. So with that, if you can rewrite this square root as x to the 1/2 power, Now we're in the situation that that exponent attached to everything on the inside here can move down in front, become a multiple, and there we have it fully expanded. A little bit more complicated one where we have a cube root of x squared. So a reminder on these that whenever you have the nth root of x to the m power, you can always rewrite these as x to the m over n power as a rational exponent. So let's rewrite this so it looks like the natural log of x to the 2 over 3 power. And then we have an exponent attached to everything on the inside of the log. We're going to move that 2/3 down in front, make it a multiple, and there we have it fully expanded. So it's always good to review over some of these exponent rules. The more comfortable you are with those, the easier these problems become. So keep practicing, you'll get it. Keep expanding these